Right. So this is Assistant Professor Singh, and we'll talk about this Booth algorithm again. So this is another example of Booth algorithm. This is 2 cross minus 8, right? So when we have 2 cross minus 8, again the same thing follows. This is the multiplier. This is the multiplicand. This is the multiplier. The multiplier will be QR bar plus 1 because it is minus. Okay, it's negative. The number that you have positive will be your BR, and if it has been a positive 8, that means it will be QR. Now if this is minus 8, that means this is QR bar plus 1. This is QR bar plus 1, right? So you have QR bar plus 1 equals to 1,000,000. Because you'll be utilizing QR, that means you have to obtain QR from QR bar plus 1. So you get 1's complement from QR bar plus 1. Then get just add plus 1, you'll get 2's complement of it. So now you have QR bar plus 1 and you have QR. We'll be using QR here, right? So it is definitely necessary to have QR over here, right? Next you have BR available. So this is BR, and since you'll be utilizing BR bar plus 1 in the calculation, you have to calculate BR bar as well. Okay, so BR bar plus 1 will be just 1's complement of it. This will be the BR bar, and plus 1 will be BR bar plus 1. So if you guys remember, we had a simple rule in case of 0 0 and 1 1, just ASHR means arithmetic shift right. In case of 0 1, you have to add BR, and in case of 1 0, you have to add BR bar plus 1, right? So these are the rules to calculate your Booth algorithm. Next you have to initialize accumulator with 0 0. QR will be this value. Qn plus 1 is the additional flip-flop that we utilize, and we initialize it with 0. Sequence counter will be equals to your number of bits in the multiplier. So if there are 4 bits, it should be 4, right? Next 0 0. 0 0 means you just have to use ASHR, arithmetic shift. So use arithmetic shift. In arithmetic shift, copy your MSB as it is and then shift the entire result towards right. So this 0 will be here, 0 0, this 0 will be here, 1 0 0, this 0 will be here, and update the sequence counter. After every arithmetic shift operation, you have to update your sequence counter. This is very important. For 0 0, again just arithmetic shift. So you shift it again, 0 0, arithmetic shift, you shift it again. Now there is this 1 0. 1 0 means you have to add BR bar plus 1. What we have in BR bar plus 1, this is BR bar plus 1. So we add BR bar plus 1 over here. Next, after addition, you'll get this particular answer, right? Now when you get answer, you have to use arithmetic shift, right? So we used this 1 as it is, then 1 1 1, this 0 will come here, this 0 will come here, 0 0, and this one will be here, and then sequence counter will be updated to 0. The moment you updated your sequence counter equals to 0, that means the calculation stops here, right? Now if this is your answer available, this is the answer, the leftmost bit will define the sign of the answer. So if this is 1, that means the answer is negative, okay? If it is 0, that means answer is positive. Now since you are multiplying 2 cross minus 8, the answer has to be negative, which is a good thing. Another thing to be noted is that if your answer is negative, that means you just can't leave your answer as it is. You have to take 2's complement of the answer. So get this 2's complement of this entire magnitude. Leave this sign, okay? Just take 2's complement of the magnitude. So the value will be 0 0 0 1 1 1 plus 1 to get 2's complement, and this will be the answer. Now 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. So 2 raised to the power 4 equals to 16, and since the answer is negative, you just put negative sign here, right? Okay, so this is both algorithm for 2 cross minus 8. Another example is if you have both operands as negative. As I told you, if you have operand which is negative, that means that is available in 2's complement form. Now again, the first will be multiplicand, the second will be multiplier. Multiplicand, that means BR, and multiplier means QR. If you have negative sign, that means you have multiplicand 2's complement. That means it is what is given is BR bar plus 1. So it is given, and I told you in the previous lecture that if the multiplier is negative, multiplicand is negative, and whatever you have calculated is having 1 at the leftmost bit, MSB, in that case you have to insert 0, your MSB cannot be 1 in case of multiplicand, which is negative. In case of negative multiplicand, your MSB cannot be 1. Just make note of it, right? So add 0 to it, insert 0 to it. Next, get BR. So just 1 is complement plus 1, 2 is complement. So this will be a BR. Similarly, whatever is given to you was minus 2. That means whatever is there is QR bar plus 1. Right. So it was 5 bits. You make this 5 bit, right? Because of adding 0. So make it 5 bit too, right? The rule that I just told you that MSB should not be 1 is only applicable with multiplicand. Multiplier does not have that condition. But you have to add this QR, right? So convert this, you get this. Now ICC should be equals to 0, 0. QR is right here. This is the QR. Qn plus 1 will be initialized with 0. Sequence counter will be equals to number of bits in the multiplier, which is 5 right now, right? Next, for the 0, 0 case, you have to keep the answer as it is. Just shift that entire answer towards right. So add 0 as it is, copy, and then just shift the entire answer. See, this is here, this is here, this is here, this is here, this is here. And update the sequence counter after every arithmetic shift operation. Next, you have 1, 0. So 1 for 1, 0, what will be the condition? Remember the condition 0, 0, 0, 1, 1, 0, 1, 1. In this case, just arithmetic shift right, add BR, and in this case, BR plus 1 will be added, right? So now you have 1, 0. 1, 0 means BR bar plus 1 has to be added. So just add BR bar plus 1. We have calculated BR bar plus 1 already. Just add it here. You'll get this answer. After every operation, you have to use ASHR. So after using ASHR, this will be the answer. Copy the sign as it is, and while shifting, you have to shift the entire value along with this QR. So you shift it from QR last bit will go to Qn plus 1, and then update the sequence counter again. Now you have 1, 1. That means no change. Just ASHR. ASHR, again the same process. Update sequence counter 1, 1. ASHR, same process. Update the sequence counter 1, 1. Now, since this is 1, 1, again ASHR, right? Count it, right? Next, now you have the answer as 0. Sequence counter is 0. That means you won't be going ahead with any further calculation. And if this is the answer, because you're not calculating anything after this, that means this will be the answer. The leftmost bit MSB will indicate the sign of the answer. If it is 0, it's a positive. If it would have been 1, that means it's a negative, right? Since this is 0, answer is positive. And if the answer is positive, you don't have to calculate 2's complement of the answer. The answer will remain as it is. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3 and 4.